This video will help you do the homework for section 3C on multiplying radicals. In this section, we're going to see that multiplying radicals is a lot like multiplying algebraic expressions. We're going to use the distributive law and we're going to use expansion, everything that we practiced in chapter 2, or reviewed in chapter 2. So if I have something like this, then I can use the distributive law, multiply the radical on the outside by each part of the bracket. So 3 times 2 is 6, and square root 5 times square root 5, remember our other rules that we learned in sections 3a and 3b, when I multiply a radical by itself, I get back the number under the radical sign. So square root 5 times square root 5 is simply 5. You can also think about it, square root times square root 5 is the square root of 25, and that is, of course, 5. Once I've done the first part, I do the second part. This minus sign has to be taken over into the final expression as well, so think of this as a negative square root 2. So 3 times negative 1 is negative 3, or minus 3. Square root 5 times square root 2 is square root 10. And the final answer is then 30 minus 3 square root 10. So I've expanded this expression by multiplying radicals. So here you can also compare this to algebra. If I think about it as minus 4 minus a or something like that, I follow the same rules. Think of this as a negative 1. Because there's no number outside the brackets. So negative 1 times 4 is negative 4. And negative 1 times a negative square root 7 is going to be a positive square root 7. Feel free at any point during this video to pause it, try the problems that are written here yourself, and then you can listen to it to see if you get the right answer. So in this third exercise, or third example, we have square root 3 times 4. That's going to be 4 square root 7. And square root 7 times a negative square root 7 will be a negative. Remember, multiplying a radical by itself gives you the number under the radical back again. So that's a negative 7. That's as far as we can go, so that's our answer. Okay, we can also expand brackets with 2 parts to the beginning, so a binomial times a binomial. I do the same thing that I do when it's algebraic. I multiply the first terms by each other. I multiply the first and last, so the outside terms, multiply the inside terms, and multiply the last terms of each binomial. Again, everything in this bracket by everything in this bracket. So 3 times 4 is 12. 3 times a negative square root 2 is minus 3 square root 2. So this minus sign from here comes out front to go out in front of the 3. Negative square root 2 times 4, again the negative sign will come out as a minus sign out in front. The whole number 4 comes first and then the square root 2. And then negative square root 2 times negative square root 2 will be a positive 2. We have like terms that can be added together. This 12 and this 2 can be added together to make 14. That's a little different than algebra, where usually the first and the last terms did not end up being like terms. This would be an x squared, and that was a constant term. But with radical expressions, they often do, and both being integers. So I get 14. And here I've got like terms with the square root 2 terms. So minus 3 minus 4, I use the rules for adding and subtracting, and get minus 7 square root 2. Remember, I cannot subtract these two from each other. I don't end up with a negative 4 under the root sign or even 0 under the root sign. It simply stays square root 2, just as if you had negative 3a minus 4a. That would also give you negative 7a. So that's why we also get here a negative 7 square root 2. Think about the radicals as little bits of algebra. There are no more like terms, So we can circle that as our final answer. Okay, the next problem, we have a squared term out here, but don't let that fool you into thinking you can do 1 squared plus square root 3 squared. This is just like when we do it with algebra. We have to expand it and make sure we don't lose the inside terms. So I would rewrite this until you get used to doing it and can see the shortcuts. But I would rewrite this like this and then expand each part separately just like we did up here. So 1 times 1 is 1. 1 times square root 3 is square root 3. Square root 3 times 1 is square root 3. And square root 3 times square root 3, that's a radical multiplied by itself, so that becomes 3. Then I look for like terms. 1 plus 3 is 4. And square root 3 plus square root 3 is 2 square root 3's. And that's the final answer. Okay, the last one, it's the same process, but it's just getting a little bit more complicated, and an interesting pattern shows up here. 2 square root 3 times 2 square root 3 is going to be 4 times 3, because the square root 3 times square root 3 becomes 3 back again. 2 square root 3 times 5 is 10 square root 3. And the inside terms here, negative 5 times 2 square root 3 is minus 10 square root 3. So you might notice those are exactly the same terms but opposite signs. We'll deal with that later. And negative 5 times positive 5 is minus 25. These two terms actually here in the middle actually cancel out. They're exactly the same but opposite signs. One's adding, one's subtracting. So in the end we get 0 out of that. And if you look back at the original binomials, we had a minus sign here and a plus sign here, but otherwise they're exactly the same. So that's very similar to the same pattern that we had with x minus 2, for example, let's just give an example, and x plus 2, that end up with this difference of squares, where we just end up with x squared minus 4 in the end. So if you remember that pattern, that's kind of what happens here too. These middle terms disappear. But what's even easier, or what becomes even simpler in these radical expressions, is that this first term, 12, and the last term, minus 25, are both integers, because the radicals have become, because it was square root 3 times square root 3, the radicals have become an integer over here with this 3. So it actually even just becomes an integer. 12 minus 25 is going to be negative 13. And that's the final answer. So maybe that shows you how important it is to always simplify radicals, because something as complicated looking as this can end up in the end just being minus 13. Okay, that's it for this section. You've got lots of time to do the homework, I hope, and get started as soon as you can. Good luck!